I'm Jacob Quinn. I work at Relational AI. We're building a cool cloud-native database in Julia, and it's a lot of fun. We have to figure out a lot of crazy details about how to deploy Julia and make it fast and have a good web stack and lots of stuff. But part of it is JSON, though I will say that JSON is a bit more of a hobby for me. If you know my history, I am a bit of a hobbyist when it comes to JSON packages. So quick history is there are actually lots of different packages to do JSON in Julia. The first one going all the way back to 2012, I looked up some history, and so before Julia even had a package manager, there was a few of these like really useful packages that were actually included in the Julia repo itself in this like extras directory, and they were just files, and you could just like include them if you wanted. And I think that's actually where data frames started as well. So there was a few of these in this extra directories in the Julia repo, and then I saw that Stefan actually moved it out into a separate repo in 2012. So that was a fun little. Yes, yeah. It was like we can't just put all the packages in the Julia repo. So that was a fun little look back in history. But I worked on the JSON 2 package in 2017. That was coming out of a need for wanting to do custom types deserialization through JSON. And it was kind of a first attempt at getting something working. Sam O'Connor came up with the lazy JSON idea in 2018, which took a very lazy approach. And he never quite finished it. So it's kind of an incomplete package, but it did have some lazy support. And then 2019, I came up with JSON 3, which, you know, you see a pattern here. It was an attempt to take the ideas in JSON 2 and make them really fast. So speed and performance was the focus there. And then, you know me, I have slowly been mulling over everything that annoys me and bugs me about all the JSON packages, and that's what I'm going to talk about today. Okay, so really, like another JSON package? Well, you know, we'll talk about kind of what form this will take later. But as for why, I've had personal gripes and itches with JSON 3. There's not really good lazy support. There's not really good, really large file support. Okay, so with JSON 3, it's kind of a one-shot. You have to read everything, and there's no kind of dealing with JSON in an iterative or you know, stream processing kind of way at all. Okay, so that was one thing that was like, yeah, it'd be nice to support that, but it really doesn't fit kind of how JSON 3 is architected. Okay, the other thing is it has this cool internal tape format, okay, that it uses when you just say JSON3.read on JSON. It gives you back this JSON3 object, okay, or array, or it's actually this binary format, okay, under the hood. That's based on the binary format in SIMD.json, okay, from Daniel Lemire, okay. But the more I was looking at it, it's like it's actually not a great format, okay. It actually wastes a lot of space, and when you start to become familiar with other binary formats, okay, like protobuf or flat buffers or even BSON, okay, they're much more memory efficient, and they have some really cool things going for them that I was like, we should just use something like that, okay? Because we're kind of, you know, wasting a lot of space, and there was people starting to want to use and like rely on the internal binary format of JSON 3, and I was like, that makes me really uncomfortable, okay? Because I can't even remember the details of like how it works sometimes, okay? The other thing is like there was lots of code repetition in JSON 3. I think we had at least 6 different implementations of like how to parse an object key value pairs, okay? Which, you know, it's not really a problem, okay, because it's pretty straightforward code, so just copy and paste it and tweak it a little bit, and that's fine, right? But it's gross, right? Like that's just, you know, it's an itch that I want to like figure out how could I have a single, you know, place where we're parsing a JSON object and be able to use that anywhere else in the package, okay? And then there was also, so JSON 3 has the support for custom type deserialization, okay, through struct types, okay, and it works pretty well. But if you peek under the hood at some of the implementation, there's some weird parts, okay, particularly with when you're dealing with unions or abstract types. it's actually a very tricky problem, okay? Because you're essentially saying, here's this JSON text, and here's a type that I want, and if that type is abstract or a union of types, how exactly do you make this turn into this, okay? That's a very hard problem to solve, okay? And it's not exactly clear what you should do all the time, okay? So let's talk about what I've been working on, okay? I'll give the preface that this is very much a hobby of mine, is like thinking through how, and this iteration is very much focused on like cleaner APIs. That was really the motivation for me, is like, how could I take all the things that I don't like about JSON 3 and make something that's internally feels very clean and very nice and all of that. This is, to some extent, a design of how this new JSON package is architected, okay? So everything starts with, you have a JSON source, and it all goes through what I call the JSON lazy value, okay? So you can call JSON lazy directly, okay? And that will return a JSON lazy value, okay? And really all that's doing is saying, let's look at the first character, and let's figure out what this thing is, and return, and that's it. Okay, and JSON's kind of cool because it has a very limited type domain, and you can do that. Okay, you can say this is a null, this is a bool, this is a number, a string, an array, or an object. Okay. Yeah, it's very cool. Okay, and it makes it so it's really fast to just return directly with a little type tag to say, I know what this thing is. Okay. From there, we have options. Okay, of things we can do with this lazy value, okay? One of the things, like I said, I wanted to support was being able to use and process lazy values in JSON, and that's where this selection syntax comes in, okay? If you're familiar with XML, it has this idea of XML path, okay? And there is this concept of JSON path. It's not super widely used or known, but it's a similar idea where you're saying, I have a JSON blob, I want to kind of navigate down maybe a deeply nested structure and pull out specific values. Or I want to recursively search and return a list of values, okay? Or I want to match on a custom function, a matching function as I kind of navigated JSON, okay? And so that's fully supported in this new model, okay? So, and it's built generically so that it works on these lazy values. So literally I can say, return a lazy JSON blob, okay? And I want to search down and extract one single deeply nested value, and it's literally only parsing as much as it needs to get to the value, and then it stops, okay? So it's very cool. It's very efficient. It's very nice, okay? It supports that. The other thing that it supports is a binary format that is very, very close to BSON, okay? That was mostly the inspiration that it took from. There's a little bit of a Julia flavor in there because the other thing I really wanted to support was arbitrary size numbers, okay? The JSON spec doesn't have a restriction on like what numbers can actually be, okay? And so you run into these weird cases sometimes where like, and this is across all languages, all JSON implementations, it's like, I have this big number that actually doesn't fit in a float64, so what are you gonna do? And it's like, well, sometimes there's a Python library that supports, their big arbitrary numbers, but a lot of these others don't, and it just gets messy sometimes. So I wanted to fully support that and say, it can handle it, whatever. And so that's built into the binary format, is saying, if it's a big int, if it's a big float, we can serialize that and we can have that supported. So that was fun too. And then also, I was like, hey, while I'm at it, the selection syntax should work on binary values too, okay? And I was like, hey, we need to make that work, and it has the same API, and it's all built on the same kind of internal interfaces. And then the other thing I wanted, which is what JSON 3 focused on and did really well, was this materialization, okay? So there's a single function materialize that you can give a type or not, okay? And it's going to fully materialize the JSON into a kind of a Julia domain objects, okay? So if you don't give it a type, it's kind of generic, dicts, arrays, strings, that kind of thing. Or you can give it a type, and this is where it follows kind of the JSON 3, where you can have some control over whether it's a mutable deserialization or this actually supports the keyword def. So if your type is defined with keyword def, it knows you can specify that, and then it'll construct it like that. Or also the default, where you just kind of pass the arguments to your constructor in the right field order. But the cool thing is like all of this kind of works together, okay? So I could go through a progression if I needed to first get a lazy value and extract a single value, and then I wanted to put that into a binary format and maybe look at things, but then I also wanted to materialize it. It all kind of works together, and they all kind of talk to each other in the right way, which is very satisfying for me, okay? Because the internals, like, they play nice with each other. So I'm going to show you a quick, what are we doing on time? We're doing okay. So I'm going to show you a little bit of this in action. I have a little Pluto notebook here. Is that big enough? Let's go a little bigger. Boop, boop. So right now this code lives here. It's this JSON base repo, and I'm adding it here. And then here's a blob of JSON that I will work with. It's kind of has some bookstore data, and there's some books in the store, and then there's a bicycle in the store, and there's some random stuff, okay? So the first thing I was talking about is you can just call JSON-based lazy, okay? And it returns this lazy object, okay? And you can see what the keys are, okay? So the show method is smart here, and it's actually walking your lazy object and showing you what's inside, okay? Which is convenient, but that's only defined in the show method itself, okay? So, and you can see that it's really fast just to make this lazy object because it's only 20 nanoseconds, okay? We're really just peeking at what's inside this JSON and then returning. So it's very, very fast, okay? It's not doing a lot. It's waiting in a very lazy way to let you pull the data through whatever operations you're looking for, okay? Yeah, question back in the back?
How far does it set by default?
That's a good question. I don't know. I think it'll fully traverse if you show it. But then I think the show method will stop at a certain point, so.
I see that causing issues with decontested JSON.
Yeah. Yeah, so maybe be careful showing it if you're worried about it.
I mean, most show methods for like arrays and even strings now do some of it.
Right.
It might be good to do that because when you have
Yeah.
a object you don't want.
Right. I think I'm hooking into the abstract dict show method. And so, I think that might be doing it. I'll have to follow up on that. Like I said, we have some of this selection syntax, okay? So here's some of the things that are supported on these lazy objects or these binary objects. Obviously, you can just get a key or an index, okay? If it's an object or an array, you can just kind of reference those however you'd like, programmatically, or like the x.key syntax. You can also just like select everything, and it'll return it as a list type. That's a special type in JSON because it then will work recursively if you're recursively searching things, okay? It knows to apply the syntax to this list thing, which is really just an array. There's also, we kind of do this, because Julia doesn't have a broadcasted get index, we do support that on the list. So you can say x.key on a list, and it will do a broadcasted get index, which is convenient a lot of the time. And then there's also this recursively select. So you can give it a key with the tilde, and it'll recursively search through an entire JSON object and find all the keys that match that type and return those as a single list. And then you can also just give it a function here and apply a key. You have to give it a key value function, okay? For objects, it'll return key value pairs, the field name and the value. For arrays, it'll be the index and the value, okay? But you give it a key value function and you return a bool for whether it should be included or not. So it's kind of like a filter function, and you can do that recursively or over all the values of an object, okay? So it's really cool. It's handy, like XML, if you're trying to extract certain things. And like I said, this works on the lazy object, so it's only going to parse as much as it needs, and it returns, and that all kind of works really well. So I just had a couple examples here of doing that. One thing to note is if I run this, it's returning. If I do a selection on a key, let's add this one up here. So if I say low.store, this is returning another lazy object, right? And that's so that everything works recursively, okay, so that I can apply things and I can do this deeply nested thing because they're all lazy objects all the way down, okay? But if I want to materialize this, okay, I've defined the empty get index as a shorthand to say, okay, now I actually want to materialize whatever is here, and so I can actually see like an actual Julia value here. Okay, so that's just a note on why you're seeing these get index brackets at the end of all these, is because I'm saying I want to lazily go to the store, to the bicycle, to the color. I want the color of the bicycle in the store, and then I want to materialize this as red, okay? Because if I didn't have these, it's still a lazy value. It's a string, and I know what that is, but it's still a lazy value in case I want to, keep going on the lazy train, okay? But yeah, there's just a couple other examples here of doing all the lazy selection stuff, which is really fun. So a quick note on the performance, okay? There should be some advantage of doing this, right? So let's look, okay? If I do a timing of lazily passing this JSON in and navigating down to the first book and getting the price of it, which is $8.95, okay? That takes under a microsecond, okay? 750 nanoseconds to do that in this lazy way, and it's pretty efficient, okay? And it's not taking up a ton of memory. If we compare that with JSON and JSON 3, okay, they have to do much more materialization here. I don't know what JSON 3 is doing here. It's super slow, okay? But yeah, I didn't look into like why is it so slow. But for JSON at least, I mean, this isn't really apples to apples, right? Because JSON is literally creating all these dictionaries and arrays and everything, and then it's extracting the value at the end. And we're literally not, okay? We're just walking the JSON itself until we get to the value we want, and then saying, parse that number, return it, okay? So that's really cool, and that's the advantage. And you can imagine having gigabyte of data and doing that, and how much more efficient that would be.
In the place where you're saying lazy JSON.store.book, could you replace that .store with a lazy value of store you pick up someplace else and have the whole tree go lazily? Where like you have one lazy value that you haven't actual materialized yet, and you're putting that into a query in a second place.
Yes, yeah. There's, are you saying for like comparison, or like what are you matching on? Because like that's the idea, right? Is I'm matching for store, right? Like it's kind of like I'm doing this. I'm doing a get index with that store, and I'm saying I'm looking for the field with the key named store. So it's whatever you're matching on.
So the value could be store, building, or road, but you won't know until you run the query
Yeah.
someplace else, but you want that as a lazy value.
Yep, that's fine. Yeah, you can pass that in as a variable. That's totally fine.
And
Yeah.
then it will materialize all of it?
No, it won't. It'll do the lazy thing. So I can even do it like this, and this isn't going to be any different, okay? So I like this store variable here. I could pass that in as something that's dynamic, and it's going to be just the same.
It's a question that can you take a sub-expression out of the first part of that and assign to a variable?
Yes, and then use it later.
So chop that query in half, take the first half of it.
Yeah, yeah, that should be fine.
That's fine.
Yeah, that's fine. Yeah, because they all return lazy objects, right? And then you can do whatever you want on the lazy objects recursively. So that's a big part of the design, right? Yeah.
Yeah, kind of piggybacking on that, is there any like in-place materialization as it actually goes through? Like I have to pass this lazy
Nope.
different functions if it's going to value twice.
Yeah, no in-place materialization. So if you're doing repeated queries, you're repeatedly parsing the same stuff over and over. Yeah. So yeah, if you wanted, you could, extract maybe a deeply nested thing, and then you could query just on that. It'll start from that object and only parse down that tree. So that's a consideration. Yeah. Or if you're doing repeated queries on this little subtree that are really heavy, maybe I extract just that subtree, fully materialize it, and then I do queries. So I'm not reparsing. Okay.
I'm a big fan of the stuff you did with struct type with JSON 3.
Mhm.
Will this new one be able to handle all that wonderful? Because I've used that in my consulting work. It's wonderful.
Yeah, it does. I think I have another slide on it. I can show it. let me show the other. I just want to show one other kind of advantage of the new binary format in the new stuff. So, I mean, obviously, yeah, not apples to apples here because JSON, current JSON package doesn't have a binary format. So it's fully materializing this. It takes about 2 microseconds, okay? But even JSON 3, it has a binary format if you just say JSON3.read. And it's pretty fast, but this one's faster, and check out the memory difference, okay? JSON 3 is just wasting so much space with everything it's doing versus this new binary format that's being careful and memory efficient and much more performant. So I just wanted to kind of highlight that. Faster and way more memory efficient. So what else can it do? It has full support for JSON lines parsing. All you have to pass is JSON lines equals true, and then it knows how to handle that and say this is a JSON lines thing. It has full multi-dimensional array round tripping. So I know that's been a long requested feature of JSON 3 that it didn't really work in the JSON 3 design, but we support it in this new stuff, which is really fun. Arbitrary dimensions, you can just say, yep, I'm going to serialize that and deserialize that. There's also been something I've wanted to do in JSON 3 for a long time, but again, like the architecture was just, it made it hard to change things, is being able to override the behavior of certain interface functions for types that I don't own, okay? And in that case, we're solving that with this new JSON style overload. So I can define my own style. It'll fall back to the default in all the cases, but if I want to override how floats are serialized, I could do that in my own kind of domain, okay? And then this is something that I have sketched out, haven't implemented yet, but it's a flattened iterator over nested structures. So as I am processing like really nested stuff, sometimes I just want to flatten it all into a single list and like process it in a stream thing. You can it's all there, right, with the lazy stuff, but I just need to package that up into like a nice flattened iterator thing. But I have ideas of how to do that. So it's really fun. So yeah, real quick. Boop.
Is that something that JSON does, right?
Yes, yeah. Yeah, so that's the idea. Yeah, that was a big idea that JSON 3 just never really supported that super well. Because I was like, no, there's a default way to do it. That's good enough for anybody. But I was like, no, actually, there's cases where you just want to customize things. So yeah, that's kind of the idea. So here's the drop the mic slide, which is I actually want to propose this as a JSON package 1.0 release. So that's my evil plan to take over the world and actually consolidate everything into one JSON package. Because I feel like, at least for me, this is the JSON package that I think will be the end of my JSON packages. And so I'm finally ready to say, yeah, I think this should be the 1.0 release of JSON. It's actually pretty close to fully backward compatible with the current JSON. And so it shouldn't be disruptive at all, but it'll provide all of this new stuff as well as people want to use it. So anyway, that's my evil plan to put in place soon. There's a few things I need to clean up and stuff, but the package is there if you want to take a look. It's mostly functional and documented and everything, and so yeah, I'm hoping it'll be a really good thing for the future of JSON and Julia. So thank you.
Thank you. Yeah. Okay, so any additional questions?
Yeah,
Go ahead.
Is the lazy data typing tab complete?
Yeah, it does. Yeah.
Oh, so like you can lazily tab complete?
Yeah. Mm-hmm.
That's so beautiful.
Yeah. Yeah, because it just relies on property names. So you can just tab complete and it knows how to find the property names and then it'll return them and you can look at them. So yeah, it's really nice. Yeah.
Yeah, go ahead.
On an unrelated question, on your slide you had materialize taking 2 arguments x and t and the type of the second argument?
Yep.
What?
So that's the case where I have a custom struct, like a person struct that has like a name and an address. And I have JSON, okay, that's a JSON object with a name and an address. And I say, I don't want to materialize this as a dictionary. I want to materialize this as a person struct.
My question is, why is the type the second argument?
Good question. Yeah, we can make it the first argument. I don't have strong feelings about that.
We are still before 1.0 release, so.
Yeah, we're pre-release anything, so this is not even published. So yeah, we can do whatever we want. Yeah, good question. Any other questions?